Now, one of the first places that we see complex numbers turn up is as the solutions to quadratic equations. So, for example, suppose we sat down to solve the quadratic equation x squared minus 6x plus 34 equals 0. Well, let's quick check how many real solutions this has by computing the discriminant. Plugging in -6 for b, 1 for a, and 34 for c, I see that this is -100, which is negative. So, this quadratic equation has no real solutions. Why did we insert that word real in there? Because it turns out it has two solutions like normal, but they're both complex numbers. How do we see that? Well, we use the quadratic formula. X equals negative b plus or minus, well, we already worked out this is -100 all over 2a. So we'll have 6 plus or minus I root 100 over 2. 100's a perfect square. So this will be 6 plus or minus 10i over 2. Just dividing term by term, it's pretty easy to see that this is going to be 3 plus or minus 5i. Now, what do we mean when we say that these are solutions to this quadratic equation? We really do mean solutions. If we plug in x equals 3 plus 5i or x equals 3 minus 5i to this quadratic expression, we really get 0. So, plugging this in, using my calculator, I find that 3 plus 5i squared is -16 plus 30i, and I can pretty easily tell that -6 times 3 plus 5i is going to be -18 minus 30i plus 34. And now I just combine like terms. -16 minus 18 plus 34 is 0. 30i minus 30i is 0i. So that does indeed give me 0. I can play the same game with 3 minus 5i. Again, using the calculator, I'll find that 3 minus 5i squared is -16 minus 30i. And again, it's pretty easy to see. -18 plus 30i plus 34. And combining like terms again, I get 0 plus 0i, which is 0. So when we say that we have complex solutions to a quadratic equation, we really mean that they're solutions in the same sense that real solutions are. When the discriminant tells us that we have no real solution, it's telling us that we have two complex solutions. Find all complex solutions to the equation 5x squared minus 6x plus 5 equals 0. And when I say this, find all complex solutions, I mean find the solutions. They will turn out to be complex. Pause the video and try this now. Alright, so in the quadratic formula we'll have x equals negative of -6 plus or minus the square root -6 squared minus 4 times 5 times 5 all over 2 times 5. So that's going to be 6 plus or minus the square root 36 minus 100 all over 10. So 6 plus or minus the square root negative 64 over 10. 6 plus or minus I root 64 over 10. 64 is a perfect square. So this is 6 plus or minus 8I over 10, or 0.6 plus or minus 0.8I. I'll leave plugging that in as an exercise to you, but these are all of the complex solutions to this quadratic equation.